Assalamualaikum, my name is Nurul Afifah Zulkifli and I'm here to present my research project entitled A Review on Removal of Sulfur Oxides and Hydrogen Sulfide Gases by Optimizing Hydrogen Peroxide Concentration. As we all know, a dramatic rise of air pollution, particularly in the emission of sulfur oxides and hydrogen sulfide in the environment, has been the major concern due to its severe environmental impacts. Emission of sulfur oxides and hydrogen sulfide gases can categorize as prominent toxicant primarily found in various industrial processes and derived from industrial feedstocks. In order to prevent the gas emission, wet scrubbing method is being implemented, which proven to have higher reliability and greater removal efficiency. Therefore, the wet scrubbing method is utilized by using hydrogen peroxide as the scrubbing liquid, which commonly known as a versatile oxidizing and bleaching agent used in a broad range of application, particularly in advanced oxidation process to remove gaseous pollutants. In this section, I will be comparing the current available conventional treatment technologies and wet method by using hydrogen peroxide. There are few pros and cons between these two methods. Firstly, membrane separation is efficient and environmental friendly, whereas it has proved to have high removal efficiency but have low anti-corrosion ability and high cost. Meanwhile, for the biological treatment, it depicts mild running condition and low cost but unable to treat high concentration of hydrogen sulfide. Chlorination method produces a significant drawback by generating chlorinated byproducts, which is halomethanes. Phantom-based oxidation method shows a narrow pH window, difficult to recovery of ion-ion, and uncontrollable reaction rate. Therefore, the limitation from the current technologies is overcome through a conventional alternative such as the advanced oxidation process, which was discovered by controlling the concentration of hydrogen peroxide in the removal process. This method is known as one of the most environmental friendly methods used due to its chemical stability to eliminate recalcitrant organic compounds that are not easily treated by current traditional processes. Due to its outstanding benefits such as low capital cost, maintenance cost, and simultaneous removal of multiple pollutants, advanced removal technology has shown a promising potential for development and deployment. Wet method by using hydrogen peroxide can generate highly reactive molecules including hydroxyl, oxygen, and hydroperoxyl, radical to eliminate gaseous pollutants by an oxidation reaction. And lastly, hydrogen peroxide is a safe chemical to store. Moving on to the objective, there are three main objectives of this review study. Firstly, this review study is conducted to deeply investigate the optimum concentration of hydrogen peroxide in removal of hydrogen sulfide and sulfur oxide gases in the wet scrubbing method. The second objective is to study the efficiency of the sulfide removal by comparing through a few main parameters, which is concentration of hydrogen peroxide, pH of solution, flow rate of gases, and flue gas temperature. Lastly, to study the stability of hydrogen peroxide as a chemical oxidant used by focusing on the trend of the removal efficiency and the amount of hydrogen peroxide used throughout the removal process. For the scope of study, this review is focusing on the wet method of removing sulfur oxides and hydrogen sulfide through scrubbing process with hydrogen peroxide. The wet scrubbing method is set up by using hydrogen peroxide as the scrubbing liquid due to its outstanding benefits and removal efficiency. In addition, the main parameter in this review, which is hydrogen peroxide concentration, is varied to 5 different concentrations from 0.25 mol per liter up to 2.0 mol per liter in order to observe the optimum concentration in removing the gaseous pollutant. The volume of the hydrogen peroxide is set into 5 different volumes, which varied from 50 ml to 250 ml. And the flow rate of gases is controlled with 5 different flow rates starting from 4 liters per minute to 20 liters per minute. Apart from that, the instrument used in analyzing the component of gases is gas chromatography, as it can efficiently analyze the component of gases more accurate compared to high-performance liquid chromatography (HPLC). In this methodology section, there are 5 main steps that need to be done before the removal process. Initially, 10% of hydrogen peroxide is prepared with 5 different concentrations starting from 0.25 mol per liter to 2.0 mol per liter. This method is done by diluting the hydrogen peroxide solution with distilled water before starting the removal process. Next, hydrogen sulfide gas with 20 ppm and sulfur dioxide gas with 1000 ppm is injected into the wet scrubber. The gases are then passed through the scrubber, whereby it was absorbed in the scrubbing liquid and oxidized by the hydrogen peroxide solution. The outlet gas was collected at the output of the scrubber and was kept before being analyzed in the chromatography. The chromatogram is used to analyze the component in the injected gas. The gases are stimulated in the oven column and the detector measured the quantity of the separated gases. Signal is generated by the detector and captured on the computer as a chromatogram. The first part of this review is to study the optimum hydrogen peroxide concentration in removing hydrogen sulfide and sulfur dioxide gases. In this context, concentration of hydrogen peroxide imposes OH free radical that will be generated during the reaction. The figure shows that the optimum concentration of hydrogen peroxide in removing hydrogen sulfide gas is at 0.2 mol per liter with 500 milliliter of volume. The method used by the researcher is wet scrubbing with vacuum ultraviolet associated with hydrogen peroxide and urea. Owing to its strong oxidizing property, the OH radical produced able to oxidize the hydrogen sulfide to sulfate through few series of reactions. Nevertheless, it is proclaimed that by adding high concentration of hydrogen peroxide will induce the reaction to form side reaction. This is due to the decreasing concentration in the liquid phase and effect in accelerating the decomposition of hydrogen peroxide. A study conducted through a wet scrubbing method was done and proved that 1% of hydrogen peroxide could remove 2,500 ppm of hydrogen sulfide with 98.7% of removal efficiency. This portrays that concentration of hydrogen peroxide has reached its maximum capacity to oxidize the hydrogen sulfide gas into sulfate. Apart from that, another removal process is done by using hydrogen peroxide associated with sodium hydroxide, which specifically act to increase the mass transfer by enhancing the dissociation of the pollutants into HS ion. This clarifies that hydrogen peroxide solution can either be used on its own or associated with other bases to boost up the removal process. Sodium hydroxide is verified as an efficient scrubbing liquid to shift the pH system to alkaline conditions. In terms of solution pH, few studies have outlined that solution pH resulted in significant outcome on redox reaction, whereby higher pH led to higher gas removal efficiency as shown in the figure. The solution pH is varied from 1.51 to 9.82, thus showing an increase in hydrogen sulfide removal efficiency. This is due to the fact that the enhancement of the alkalinity, which is solution pH, will effectively improve the ionization process. The removal process of the gas generates a large number of H+ ion in the solution. Consequently, when the OH ion is added into the solution via an acid-base neutralization reaction, it can effectively absorb the H+ ion, thereby improving the gas oxidation absorption process. The gas flow rate is a crucial parameter in removal of sulfur oxides and hydrogen sulfide gas. In the situation where the diameter is kept constant, an increase in gas flow rate will effectively increase the velocity of the gas passing the equipment used, which is the scrubber. The explanation for this outcome is that increasing the gas velocity would decrease the hydrogen sulfide residence time in the reaction region, subsequently make it deleterious to the hydrogen sulfide removal. In this connection, the volume ratio is used to evaluate the concentration of the free radicals and the contact time between the hydrogen peroxide and the catalyst in the stimulated flue gas. This can be inferred that higher volume ratio led to higher contact time between the hydrogen peroxide and catalyst, which produce more OH radicals. Besides, the annihilation of OH radicals can be facilitated by longer contact time. The increase in the volume ratio therefore significantly reduces the removal performance. Similarly, raising the liquid-gas ratio will improve the transfer of gas-liquid mass by improving the disturbance in two-phase gas-liquid, thereby further supporting the removal of the gases. The temperature may also have a major impact on the removal of sulfur oxide and hydrogen sulfide gases. Several literatures have proved that increasing the temperature of the gas may lead to higher removal efficiency. As demonstrated in the figure, increasing the temperature of the simulated flue gas with 99% removal has a considerable impact on sulfur dioxide removal efficiency. Mostly, when the temperature of the simulated flue gas increasing, the rate of diffusion of gases and species such as OH radicals, hydrogen peroxide, and oxygen is increased in the oxidation reactor, hence resulting in a rise in the oxidation rate. The reaction activation energy of oxidation with hydrogen peroxide or oxygen is much greater than that of oxidation with OH radicals because of the lower oxidizing ability of hydrogen peroxide and oxygen. For the OH radicals, well-dispersion of simulated flue gas and acceleration of the oxidation reaction are favorable. The temperature of 228 Kelvin is therefore found to be the optimized temperature for the removal process of hydrogen sulfide gas. As for conclusion, it can be concluded that the most promising method of removing hydrogen sulfide and sulfur dioxide is by using wet scrubbing method with 1% of hydrogen peroxide. From the economical aspect, this method is proved to be viable as lower volume of hydrogen peroxide with 378 ml could remove 2,500 ppm with the 98.7% removal efficiency, compared to others method which utilize higher volume. On top of that, a higher concentration of hydrogen peroxide is revealed as the optimum concentration, as few studies have shown a positive result with the range from 0.2 to 1.5 mol per liter. In terms of pH of solution, the most preferable pH is estimated between the range of 3.2 to 11.56 for the wet scrubbing process with the hydrogen peroxide. There are few similarities and differences between all the methods that have been reviewed. The similarities include setting a high concentration of hydrogen peroxide in order to increase the effectiveness in the removal process. The recommendation for future planning includes conducting the experiment by using different parameters to study the removal efficiency trend from various aspects. Also, other recommendation that should be made is by performing the gas analysis using UV-VIS to compare the accuracy of the result with gas chromatography. Lastly, the gas analysis should be performed for a longer time in order to obtain the most accurate composition and peak high of the gases. That's all from me. Thank you.